A short robotics clip started spreading online recently, and the moment people saw it, something felt different. At first, it looked like a normal demo, a humanoid robot standing in a workspace, moving slowly, adjusting its balance, reaching for objects. Nothing unusual, because robots have been doing things like this for years. Factories use them, warehouses use them. Even humanoid robots have been around for a while now. So at first glance, this didn't seem like anything new. But then something changed. The robot didn't just move, it adjusted, it reacted. It corrected itself in real time, almost like a human would. And that's the moment people started paying attention. Because this wasn't just a robot following a fixed sequence anymore. This looked like something else. This looked like a system that understood what it was doing. And the robot behind that moment? Tesla's Optimus. Now on the surface, Optimus is just another humanoid robot. It walks, it lifts objects, it performs simple tasks. And if you've seen robot demos before, you might think this is just another step in the same direction. But this is where things start to get interesting. Because Optimus isn't being built just to demonstrate movement. It's being built to work. That's a very different goal. Most robots you see are designed for controlled environments. They follow pre-programmed instructions. They repeat the same actions over and over. But Optimus is being designed for something more flexible, something more unpredictable, real-world environments. Now think about what that actually means. A robot working in the real world doesn't just execute commands. It has to deal with change. Objects are not always in the same place. Lighting changes. Humans move around. Unexpected situations happen. And handling that requires something more than just movement. It requires awareness. And this is where Optimus starts to separate itself. Because instead of relying only on rigid programming, it's being combined with AI systems that can interpret the environment. So instead of just following steps, it observes, it processes, it reacts, and then it acts. That might sound simple, but it changes everything. Because once a robot can adapt, it stops being a machine that repeats tasks. It becomes something that can handle variation. And that's the key to real work. Now this idea of robots working alongside humans isn't new. But what's new is how quickly it's progressing. Because at the same time Tesla is developing Optimus, other companies are pushing similar systems forward. In China, humanoid robots are already being tested in manufacturing environments. Some of them are moving materials. Some are assisting workers. Some are even being trained to perform tasks that require coordination and precision. And that's where the bigger picture starts to form. Because this isn't just one robot anymore. This is a shift across the entire industry. Now, here's where things start to feel different. Because once robots can operate in real environments, the question is no longer whether they can work. It becomes how much work they can take over. At first, it's small tasks. Repetitive actions, simple processes. Things that don't require complex decision-making. But over time, those tasks expand. Because the systems improve, the robots become more capable. The AI gets better at interpreting situations. And gradually, the range of tasks increases. Now this is where a lot of people start asking the same question. What does this mean for human workers? And that's a complicated question. Because on one side, robots can increase productivity. They can handle dangerous tasks. They can operate continuously without fatigue. They can improve efficiency. But on the other side, they can replace roles. Especially roles that involve physical labor. And that's where the conversation shifts from technology to impact. Now, to understand how far this could go, we need to look at how these systems are being designed. Because Optimus is not just a mechanical system. It's being connected to AI models that can process information in real time. These models analyze visual input. They recognize objects. They understand context. And they help the robot decide what to do next. So instead of hard-coded behavior, you get adaptive behavior. And that's a major difference. Because traditional robots struggle outside controlled environments. But adaptive systems can handle change. And that makes them much more useful. Now this might sound like something far in the future, but the reality is, it's already starting. Because companies are testing these systems in real scenarios. Warehouses, factories, logistics environments, and each test provides more data, more improvement, more capability, and that's how progress accelerates. Now, another reason this is happening so quickly is because of how AI itself is evolving. Because the same systems that power chatbots and language models are now being integrated into robotics. And that creates something new. A system that can both understand and act. And that combination is powerful. Because understanding without action is limited. And action without understanding is rigid. But when you combine both, you get flexibility. And that's exactly what these robots are starting to achieve. Now, while all of this is happening, something else is becoming clear. This is not just about individual robots. It's about systems. Because once multiple robots can operate together, things scale. Tasks can be distributed. Workflows can be automated. Entire processes can run with minimal human involvement. And that's where things start to move fast. Because companies don't adopt technology slowly when it improves efficiency. They scale it. Now, of course, there are still limitations. Robots are not perfect. They make mistakes. They struggle with complex environments. They require maintenance. And real-world conditions are unpredictable. But the key point is not where they are now. It's where they're heading. Because every iteration improves. Every test adds data. Every update increases capability. And over time, those improvements compound. Now let's step back for a second. Because what we're seeing with Optimus is part of a much larger trend. A shift toward automation that goes beyond software. We've already seen AI automate digital tasks. Now we're starting to see it move into the physical world. And that's a much bigger change. Because physical work is a large part of the global economy. Manufacturing, logistics, construction, retail. All of these industries rely on human labor. And if even a small percentage of that work becomes automated, the impact is massive. Now, this doesn't mean everything changes overnight, but it does mean the direction is clear. More automation, more integration, more capability, and over time, more replacement. And that's why moments like that initial clip matter, because they show a glimpse of what's coming. Not in theory, but in reality. Now, one of the most interesting parts of this shift is how people react to it. Some see it as progress, efficiency, innovation. Others see it as a threat, uncertainty, disruption. And both perspectives are valid, because technology always brings both opportunity and change. Now the difference this time is the speed, because AI is moving faster than previous technologies. And robotics is now benefiting from that speed, which means the gap between development and real-world impact is shrinking. And that's why this feels different, because it's not just an idea anymore, it's starting to happen. Now looking forward, the question is not whether robots like Optimus will improve. They will. The question is how quickly they will reach a point where they can operate reliably at scale. Because once that happens, everything changes. Workflows, industries, jobs, and the way humans interact with machines. Because at that point, robots are no longer tools. They become part of the workforce. And once that happens, the definition of work itself starts to evolve. So the real question isn't whether robots will become more capable. It's how quickly they will become capable enough to change the system around them. And more importantly, whether we're ready for that change when it happens.